So let's begin the reaction with an example. Uh, let's suppose we have a benzene ring and ethyl chloride, ethyl chloride. Okay. So what's gonna happen? In the Friedel craft alkylation, the benzene and the alkyl halide gonna react together in presence of an Lewis acid uh, to give rise to alkylated benzene, which is the general basic reaction. Okay, so let's draw our alkyl. Uh, so we have our benzene, and then we have our alkyl halide. Then we will take the our reagents, which is Lewis acid. In this case, let's suppose we take aluminum chloride. Okay, so here we have aluminum with three bonds. So here we have ACl. Here we have HCl and HCl over here. Okay, so we have LCl3. We all know that the aluminum chloride is a Lewis acid because it has a vacant p orbital. So what's going to happen is the chlorine is going to donate its lone pair. Okay, the chlorine has lone pair and it is going to donate it to AlCl3 to form a complex like structure. And due to this, the chlorine is going to be removed from the R group, which is here ethyl, and form a carbocation and make it form a carbocation. So let's draw the reaction over there. So what's going to happen is first we will get a carbocation, ethyl carbocation in this case. Then we are going to get an alkyl, sorry, an complex, aluminum complex with four chlorides in it. So let me just paste it over there. So AlCl with another Cl, okay, with and now the aluminum has satisfied octet and a negative charge in it. So this is the complex itself. It is pretty good, well stabilized. So it's not gonna affect the reaction that much. So what's gonna happen is then we have an ethyl carbocation and we have benzene. So the benzene will act as a nucleophile. Let me just shift the benzene to here and shift the carbocation over here. So here we have our electrophile. Here we have an nucleophile. So this is a simple, now it's a simple electrophilic substitution reaction. So what's going to happen? That benzene is going to donate its pi bonds to the carbocation and form a sigma complex. Okay, the sigma complex it somewhat looks like this. Let me just draw it. Wait a second. Yeah, and here we have a cation. So this is going to happen, and this is not the RDS. Yes, I was wrong. This was the RDS because in this step the uh, what what you say the benzene lost its aromaticity. Okay, so it was then 6 pi electron system. Now it has now only 4 pi. So it's now not aromatic. Okay, so what's gonna happen as soon as it's formed, it's not going to stabilize well, and elimination will occur. We all know that here we have an hydrogen. Okay, let me just draw it. So what's going to happen is the hydrogen is gonna leave as H plus, and which will in fact shift the sigma bond pair, the CH sigma bond pair to the carbocation and form a. So let me just. It's hard to draw here, but it's going to happen like this. This bond will shift towards the carbocation. Okay, so we will get something like this. And what happened to the remaining H plus? The H plus that left. So just let me just take that AlCl4 complex. So we know that the LCl4 complex is still in the medium. Okay. So we have the left H plus is still in the medium. Okay. So it has a positive charge and they're gonna react together to form LCl3 and HCl. So they will form the your AlCl3. So let me just draw the AlCl3. Okay, so now the AlCl3 is formed and we have our HCl. So this is pretty good. This is all the reaction that oh, this is the Friedel alkylation fact. So it's pretty simple reaction. Now let's talk about its demerits. What are the drawbacks of doing or alkylating an aromatic system through Friedel alkylation? Okay. So let's suppose we have again taken a benzene system. Okay. Let's suppose we take an naphthalene system. Okay. Yes, now go. Then, or it's just benzene. Okay. Then we will take another type of alkyl halide. Let's suppose it looks somewhat like this. Okay. And we will take the same AlCl3. Here we have Al and three Cl bonds. Here we have Cl, Cl and Cl. Okay, so here we will get so these will two will react with to form AlCl4. I'm not writing that again, but one thing which is important is that we will get a carbocation like this. So let's just draw that carbocation. Where are you, carbocation? So okay. So as we can see, this is not a stable carbocation. It can rearrangement. It can take rearrange to form several different type of carbocations. So here we have one hydrogen. We all know that which is going to alkyl shift to form another type of carbocation which looks like this. So here we have two types of carbocation. So these two type of carbocation although it's relatively less stable and this one is more stable. This is less stable carbocation, but still it has some existence in solution. So we will get different temperature. So benzene can react with this one and this one also to get two different type of. Although this one will give the major product and this will give the minor product, but still the benzene will react with both. So let's find out what's gonna happen. So benzene will react. So let's take this one here. Okay. So benzene will react with this type of system to form a product like this. Here. here, here, and here. Okay. Now benzene also will react. I'm not going detail about the mechanism because I hope you can know it better. So benzene will react with this type of a carbocation and form something like this here, here, sorry, here, here, and here. Okay. So as we can see, there are two types of product. So it reduces the selectivity, and we will again have to separate these two products from the solution, which is the huge demerit of Friedel-Crafts alkylation. So this was all about Friedel-Crafts alkylation. Hope you will like it. So bye bye.